Hello everyone, my name is Alvaro, and in this video I will be solving another problem from the blind Leetcode 75 problem list. Today I will be doing problem 268, which is called missing number. So let's get to read the problem statement. Given an array nums containing n distinct numbers in the range 0 to n, return the only number in the range that is missing from the array. So we have this number right here, which can go from 0 to 3, and 2 is missing. So the number that we return is a 2. Similarly here, we have two elements. So the numbers go from 0 to 2, and one of them is missing. And as we can see, the one that's missing is a 2 here. Here, the numbers go from 0 to 9 because the length of this array is 9. And there's one number missing, and that number is 8. So how do we solve this problem? Well, let's think about the easiest way to solve this problem, right? That will be the naive solution. That will involve simply using a hash set, right? And as what we can do is simply use a hash set in which, while we loop through the nums array once, right, we store every number in the hash set. And then what we can do is simply do a for loop in the range from 0 to n. And whenever one of the numbers in that range is missing, then we simply return that number. Now, that solution uses big O of n space, and it also loops through the array twice. It works time complexity-wise. I mean, this problem cannot be solved in less than big O of n. However, you can solve this problem in just one pass and also using big O of 1 space. It is true that you can use Gauss's summation formula to solve this problem. So for example, any number in the range, like the sum of the numbers from 1 to n, for any n, is equal to n times n plus 1, divide that over 2. So you just simply calculate that using the length of the array. And then what you can do is just subtract each number from the array, from the Gauss's sum. And whatever result you end up getting after subtracting all the numbers is the number that's missing. And that solution works. It uses big O of 1 space and it runs in big O of n. But the purpose of this video is to discuss the solution that uses bit manipulation, okay? And that's the solution that we are going to be discussing now. So if you want to pause the video to find the solution yourself, now would be a good time because I'm going to get to explain it now. Okay, so before discussing the solution, I'm going to explain a little bit the operation that we're going to be using, the bit operation that we're going to be using to solve this problem. And that'll be the exclusive OR, which is shortened by XOR. So let's see what XOR is and discuss some of its properties, okay? So let's start with a simple example. Let's say we have this array right here, numbers. These are all the numbers from 0 to 3, just represented in binary. XOR is a bit operation in which when you XOR two numbers, the result of each bit will be determined by this logic. If the bits at the same positions are the same, then XOR returns a 0 for that position. And if the bits at the same position are different, then XOR returns a 1 for that bit. So here, the first bit and the first bit are the same, so it returns a 0. The second bit and the second bit are different, so it returns a 1. Let's start with a harder example. So let's say, suppose we have something like that, and then this has 3, 6, 7. Okay, so let's do something like, okay, and that should work. Okay, so let's XOR this. So the first bit is a 1 and a 1, so XOR 1, 1 returns 0. 0 and a 1 are different, so it returns a 1. 1 and 0 are different, so it returns a 1. 0 and 1 returns a 1. 1 and 0 returns a 1. 0 and 1 returns a 0. 1, sorry, because they're different. And 1 returns a 0. So let's double check it again. The first one and the first one are different. so it returns a 0. The second one, the first one and the first one are the same, so it returns a 0. The second one and the second one are different, so it returns a 1. The third one and the third one are different, so it returns a 1. The fourth one and the fourth one returns a 1 because they're different. The fifth one and the fifth one are different, so they return a 1. And the penultimate and the penultimate are different, so it returns a 1. And the last one and the last one are the same, so it returns a 0. So you get the basic idea, right? So let's discuss some of the properties. One that'll be pretty easy to see if you've toyed with this a little bit before you've watched this explanation is that when you XOR any number by 0, 0, right? Let's start with another property. So when you XOR any number with itself, when you XOR any number by itself, right, you will always get 0, 0. Like you will always get the 0 because XOR returns 1 only if the digits for that bit are different. But if they're the same number, then obviously they'll have the same bits. So everything will be a 0, right? So any number by itself, any number XORed by itself will be a 0. And then another property is that the order in which you do the XOR does not really matter. So let's start with XORing all the like all the numbers in this array right here, 0, 0, 0, 1, 1, 0, and 1, 1. So let's do first 0, 0, XOR 0, 1. This yields 0, 1. 0, 1, XOR 1, 0. Let's type XOR. Maybe it's easier to see this way. This yields 1, 1. And then we do 1, 1, XOR 1, 1. While using this property, we know that any number XORed by itself will be a 0. So this will be the result of XORing this array. If we XOR this number, and then the result of that with this number, and the result of that with this number. But let's try a different order now. Let's start with, let's say, the fourth and the second, and then we XOR it with the first number, and then the third. So let's start with XORing these two. This yields a 1 and a 0. Then we do the first number. That yields that. And then we XOR it with this number right here. Yields again the same result. Let's try one more. So let's start with the third and the first. Then we can do the fourth and then the second. So let's do 1, 0, XOR 0, 0, 1, 0. Then we do 1, 0, XOR 1, 1. This yields 0, 1. And then we do 0, 1, XOR 0, 1. And that yields again 0, 0. So as you can see, right, XORing, the order in which you XOR does not matter. Okay? So knowing these two properties, can you think of a way in which you can use these properties to find the missing number in an array? I'll give you a little bit of time to think. You can pause the video now if you want, and I'm going to discuss that approach now. So it turns out that we can simply use these two properties to find the missing number. And how are we going to do this? So let's start with the example that's given here. I think it'll be easy to see. So we have the following numbers. We have 1, 1, so that'll be a 3. We have 0, 0, and then we have a 0, 1. And obviously the number that's missing here is a 1, 0. So we want to find a 1, 0. So remember that any number XORed by itself, right, will be a 0. So what if we simply XOR, we know that the numbers also go from 0 to n, right, where n is the length of the array. So we have 3 elements. So what if we XOR all these numbers with every number from 0 to 0. So let's say, for example, we do a 0, 0, we have a 0, 1, we have a 1, 0, and a 1, 1, right? The idea here is that you can always create a pairing, right? So this 1, 1 exists in the array, the 0, 0 also exists in the array, and the 0, 1 also exists in the array, right? XORing these numbers will always yield 0, like this one with this one yields a 0, this one with this one yields a 0, and this one with this one yields a 0. And any number that's XORed by 0 will always yield itself. So what we can see is that if we XOR all these numbers, right, eventually we will end up with a 1, 0. So here we do 0, 0, 0, 1, 1, 1, and these yield 0, and then we XOR 0, 0 with 1, 0, and then that returns a 0. 1, 0, sorry. Because any number XORed by 0 is the number itself. And the main idea behind this also is that the order in which you XOR does not matter, right? As we discussed earlier. So suppose that, for example, we start XORing a 1, 1 with a 0, 0. Then we do a 0, 0, right? Because it will be the first element that we do from 0 to n. Then we XOR 0, 0 with 0, 1. And then we XOR 0, 1 with 1, 0. And then at the end, we will simply have a 1, 1 that we will XOR everything for, right? So these are all the numbers. Sorry, this will go here. So these numbers on the right, on the column on the right, represent the numbers from 0 to n. And these numbers right here represent the numbers in the nums array. As we can see, right, since the order does not matter, we can flip these around. So we can put this one here. We can put this one here. And, sorry, that one, we'll copy paste this. We can switch the elements around, right, to find that the only element that does not map to anything is the one that's missing, right? So that'll be the approach that we're going to use. We're going to start, obviously, since the numbers go from 0 to n, and whenever we're doing a for loop, right, the idea is that we do a for loop from 0 to n minus 1, because in total there are n minus 1 elements in the array since one of them is missing. The idea is that we're going to XOR every number in nums with a number in the range from 0 to n minus 1. And to be sure that we include the last number, because remember that if we do, for example, if we have 3 elements in the array, right, and we go on a loop from a range from 0 to 3, since the last number is not exclusive, then the for loop will we'll go through our iteration 0, 1, and 2. So the idea is that we start with a variable that we can call like a missing number or something, right? And that'll always equal n. So the missing will always equal the length of nums. In this case, if we have 3 elements, right, the missing will be equal to 1. And simply what we do now is we XOR this number with whatever iteration of the for loop we're in, and the equivalent, so if we are at iteration I, then we just simply grab num sub I and XOR I with num sub I and with missing. So for example, we start with 1, 1, right? And then we go with a for loop from 0 with range 0 to 3. Sorry if the explanation is a bit weird, but this will make sense now. So we start with a 1, 1, right? Because that's the length of this array. And then we start with the 0, so I equals 0. So what we're going to do is we're gonna XOR 1, 1 with zero, 0, which is I equals 0, and nums sub I, which is nums sub 0, which is 3. And that yields 1, 1, 0, 0, and that yields a 0, 0 in total. Then we do now with I equals 1, so we XOR 0, 0, XOR 0, 1, because that's, sorry, I'm getting some emails on my phone. There you go. Do not disturb. Perfect. And then we XOR it with nums sub 1, which in this case is 0, 0. And that yields 0, 0, 0, 1, 0, 1. And then I equals 2. We XOR 0, 1 with 1, 0, because that's a 2. And then we XOR it with a 1 right here, which is nums sub 2. And that yields 0, 1 XOR 1, 0 is the same as 1, 1. And then 1, 1 XOR 0, 1 yields 1, 0, which is the number that's missing. So that's the main idea. We have the mapping from 0 to n, which is represented by the for loop. The values that I take in the for loop is 0 to n minus 1. And this number right here is taken by just simply initializing missing to this. And then we just XOR every number that we encounter in nums by every number in the right column. And eventually the one that does not have a mapping is the one that's missing. So that'll be it. So let's get to code it now. So we can say something like missing number, yeah, is equal to the length in nums. There you go. And then simply what we can do is we can say for I in range length of nums, which again is the same as missing number. But actually, since it'll change, let's do length of nums. The idea is that we XOR this number, and the XOR operation in Python, it might be like a way to write it that you've never seen before, but it's this. So this will be the XOR is equal to I XOR nums sub I. And we just keep doing this, and as you saw before in the example, this will be the resulting, the result of XORing all the numbers together will yield the missing number. And this algorithm should work. There you go. Obviously, runtimes are a bit inconsistent, but eventually it beats most of the solutions in Python. There you go. That's good enough. And yeah, that'll be pretty much it. Let's discuss the runtime of this algorithm. The runtime of this algorithm is big O of n, where n is the number of numbers in the array. And the space-time complexity is big O of 1 because we're simply storing just one variable, and that's not... that does not depend on the size of the array. So it's just big O of 1. And yeah, that'll be it. I hope you enjoyed the video. I hope the explanation was not very confusing. And yeah, and make sure you hit a like on the video, subscribe, and all that stuff, which helps a lot the channel. And see you in the next one. Bye-bye.